Greetings, I'm Dev the developer.
And I'm Glitch. I'm the one who's going to make sure your code doesn't just work, but works with style, and maybe a little bit of menace.
Every program we've written so far has one problem. The moment it exits, all of its data is gone. Today, we fix that. We write to files on disk and read them back so data actually survives. Think about what happens in memory when a program runs. Every variable you declare lives in RAM. Integers, strings, lists, all of it. When the process ends, the operating system reclaims that memory. All that data, gone. Not a trace.
So we've been building digital goldfish, great. Ooh, a variable, and then bam, process ends and it's like it never happened. Pathetic.
Exactly. Files are different. A file lives on disk. The disk doesn't care that your process ended. A program that writes its state to a file before exiting and reads it back on startup is a program that actually remembers things.
So my to-do list is basically a memento simulator. Every time I close the window, I have to tattoo my tasks on my arm just to remember them.
They're there next time. That's the whole concept. And here's the pleasant part. C# gives you a class called File with a capital F. It's a static class in the standard library. No new, no objects to create. Just call its methods directly and it handles everything.
Static, no new, that's almost too easy. What's the catch? Does it require a blood sacrifice or just a very specific using directive?
Not for this. .NET 10 System.io is included via globals using automatically. File is just there. Let's write to disk. The simplest method is File.WriteAllText. You give it a path and a string, and it writes a string to that file.
File.WriteAllText, 2 arguments, 1 file name, 1 string, and 0 respect for existing data. I like its style. It's aggressive, like me.
Written, no error. Something happened on disk. What do you think happened?
I've sent hello.txt into the digital abyss. It's probably hanging out with all those single socks and deleted tweets.
Hello.txt is a relative path, relative to the current working directory. When you run this through Visual Studio, that's relative to where the application was built and is being ran from. The file is there. Now let's prove it just by reading it back.
File.ReadAllText, same path. It should hand me back the entire file as one string. WriteAllText wrote it, ReadAllText reads it. The perfect circle of life.
Written from the write call, then hello from C# read back from disk. The string went into a file and came back. It was never in a variable between those two calls. That's persistence.
It's alive, it's alive. The string survived the process death. We've achieved digital necromancy, dev. The file is the anchor keeping our data in this reality.
One thing worth noticing, WriteAllText doesn't append, it replaces. If that file already had content, WriteAllText would erase it completely and write from scratch, the whole file every time. We'll come back to that. First, let's talk about multiple lines.
Right now we're writing one string, but what if I have a whole list of tasks and want each task on its own line? Do I just join them with \n like a barbarian?
You could, but there's a cleaner way. File.WriteAllLines takes in a collection of strings and writes each one as its own line. The reverse is File.ReadAllLines, which reads the file back as a string array, one element per line.
A string array? Because why return a nice, flexible list when you can return a rigid, unchangeable array? Thanks, C#, really. I'll just use .toList and pretend this didn't happen.
It is. If you need a list, you call .toList on the result. Let's just write it up.
A list of 3 tasks. WriteAllLines sends them to the file, 1 per line. ReadAllLines brings them back as an array, then a for each to print them. Standard procedure.
All 3 tasks came back. Each line from the file is one element in the array. And if you needed a list, you'd just write dot to list after ReadAllLines.
Okay, so I can write a list to disk and read it back. But what if tasks.text doesn't exist? If I try to read a file that isn't there, is the program going to throw a tantrum?
It throws a file not found exception. Your program crashes on the very first run, before the user has added a single task. Let's actually see that happen. It's important to see that failure before the fix.
Reading from nope.txt, which I know for a fact does not exist, this is going to be spectacular. 3, 2, 1, crash.
File not found exception. The runtime found no file at the path and threw rather than hand you over back something that's undefined. This is the crash every persistent program hits on first run if you don't guard against it.
So I have to ask permission from the disk before I touch its stuff? Fine. Excuse me, Mr. Hard Drive, may I please have my bits back? File.Exists it is.
That's the fix. But instead of appending the fix below the crash code, let's replace those 2 lines. Swap them for the proper version.
File.exists on the path first. If it's there, we read. If it's not, we print a message and move on. No crash. Data.txt doesn't exist yet, so we should hit the else branch. Tactical avoidance of errors.
No file found, starting fresh. The exists check returned false. We hit the else and no exception. That is the first run pattern. Every persistent program needs this.
Check first, then read. Never read blindly. Got it. Now you said WriteAllText replaces the file. If I call it twice, the second call nukes the first. I want to see the carnage.
Good instincts to verify. Show me what you expect to happen.
I expect it to behave like a normal human or robot and just add the new stuff to the end. Like a civilized being. 2 calls, 2 entries. Obvious. 2 WriteAllText calls, first entry, then second. I'm expecting a nice little list. Don't let me down, C#.
Okay, second entry. The first write is gone. WriteAllText replaced the entire file. No warning, no error. It just overwrites.
That is cold-blooded. It just erases everything without even a may I. It's like the Death Star of methods. One blast and your whole planet of data is just dust.
This is the most common mistake with File.io. People use WriteAllText when they mean AppendAllText. AppendAllText adds to the end of the file without touching what's already there. If the file doesn't exist, it creates it. If it does, it adds to the end. Let's fix the log example.
AppendAllText, now that's more like it. It's like a persistent stalker. It just keeps adding more and more information until you're forced to deal with it.
All right, let's run it. Two entries, both timestamps, both preserved. That's AppendAllText. Use WriteAllText when you want to replace the entire file. Use AppendAllText when you want to add to it.
Replace for state snapshots, append for logs. Simple, efficient, unlike your explanation of why we're still using relative paths.
Exactly the distinction. Now, let's talk about paths. When you write data.txt, what does that actually mean on disk? Where does C# look?
The current directory, but which one? The project folder, the folder .NET Run is called from. I don't exactly have the force to guide my file searches, dev.
That's an important thing to verify. You can call directory.getCurrentDirectory to find out exactly where the program is rooted. If files are going somewhere unexpected, that's your diagnostic. And there's a Path.Combine, which is the safe way to build paths that work across operating systems.
Directory.getCurrentDirectory, then Path.Combine builds a path from components. Data and notes.txt, it'll pick the right slash so I don't have to.
That's the working directory, and there's the Path.Combine built. On Linux, it's a /. On Windows, it would be a \. Same code, correct result on both systems.
Manually building paths is for people who like to watch the world burn, or people who only use one operating system. Both are equally dangerous.
Correct. Windows uses \, Linux and Mac use /. If you hardcode either one, you've written code that breaks at least one of the three major platforms. Path.Combine picks the right separator for whatever system it's running on. Use it whenever you are building paths from parts.
I find your lack of cross-platform support disturbing. Fine, Path.Combine is the way. Happy now.
Portability. Right. Now let's talk about exceptions. File.io has a few specific ones worth knowing. We already saw a file not found exception, but there's a broader one called an IOException.
An IOException covers what exactly? Is it just a fancy way of saying the disk is angry?
Any general input-output failure. Disk full, file locked by another process, the directory you're writing to doesn't exist. A file not found exception is actually a subclass of an IOException, so it's a more specific version of the same family. There's also an unauthorized access exception for when you don't have permission to read or write a particular file.
So File.Exists for the first run stuff and try-catch for the real-world chaos. Expect the unexpected, like a digital Boy Scout with a grudge.
Exactly. They're complementary, not redundant. File.Exist handles a common case, which is first run, file doesn't exist yet, and no exception needed. The try-catch handles the rare failures that exist can't prevent. The disk fills up between the exist check and the read. The file gets locked by another process. You need both. Let me show you the full defensive load pattern.
Load data method, first check exists, no file, get out early with empty string, then the try-catch for the real nastiness. Never a crash, always a result.
No data yet. My data.txt doesn't exist. The exist check returned false. Load data returned an empty string. The caller handled it. No crash, no noise.
Okay, so that's my boilerplate for survival. Check first, wrap in a try, return something usable. The users will never know how close they came to the digital abyss.
That's the right shape. One more thing before we wrap up. Everything we've done with ReadAllText and ReadAllLines loads the entire file into memory at once. For small files, that's completely fine. For a to-do list with a few dozen tasks, ReadAllLines is the right tool.
But what if the file is huge? Like if someone ran the append log for 3 years and it's gigabytes of timestamps? I don't have enough RAM for that kind of baggage.
Then loading it all at once would fill your memory. For that case, there's StreamReader. Instead of loading everything, StreamReader reads one line at a time, so memory usage stays flat no matter how big the file is. The pattern uses using var to make sure the file handle gets closed automatically when you're done.
Using var on the StreamReader, no manual close needed. The block ends, the handle dies. One line at a time. It's the inception of reading layers upon layers, but we only deal with one at once.
All 3 lines. StreamReader read each one from disk and printed it, never holding the whole file in memory. For the work you'll be doing, ReadAllText and ReadAllLines are the right tools. Files are small. StreamReader is there when you are dealing with genuinely large files.
Small file, read it all. Big file, stream it. Use the right tool for the job or go home. I like it.
WriteAllText writes a string, creates or replaces. ReadAllText reads the whole file as one string. WriteAllLines writes a collection, one line per entry. ReadAllLines reads it back as a string array. File.Exists guards your reads. AppendAllText adds without replacing. Path.Combine builds paths safely across platforms, and for heavy loads, StreamReader processes one line at a time.
The scary part is over. Now it's just a matter of deciding which tool to use to bend the file system to my will. I am the master of my disk. I am the captain of my bits.
And once you see that each method does exactly one thing, the whole thing stops being intimidating. Write or read, replace or append, one string or many lines, big file or small. The complexity is a veil. Underneath is just a handful of simple decisions. Write a program that saves something and loads it back. Prove that it survives. Don't just watch it, do it.